Okay, we are back live, and we've got some stuff to do. I really want to do this hyperparam sweep stuff, but I got a couple things to do first. So I think probably hyperparam sweeps are going to be for tomorrow. We'll start on carbs tomorrow. What's today? Today's Friday. Yeah, today's Friday. So we're going to start on hyperparam stuff tomorrow. Right now I need to start on this other thing here. Where's the paper? This thing. This really shouldn't be that hard to implement. So let's just do that. And puffer tank. Yeah. So we're going to do E3B. And there shouldn't be that much to change here to support this. I need to add a buffer for a matrix is all. Yeah. I think we're going to just do this single purpose. So we kind of just do this in a branch, and if it's good, we'll add it to the implementation. If it's not, we're not. We won't. Okay, so LSTM state. Experience. So this goes into experience, right? And then this is going to be, we'll call this E3B matrix or covariance. How about E3B mat? E3B mat. Where's hidden dim? LSTM.hidden size. Is there no there's no hidden dim? That seems weird to me. Where's hidden dim? Uh-oh. Could have broken? I hope not. We were messing around with Isaac Gym and stuff. Why are my overlays not working? get the chat up here. Cool. How's it? I thought I branched off 2.0. PufferLib does not require. Okay, I don't know what the fuck is up with this, because this makes... That doesn't make sense. This is just a container being screwy. This should be a fairly small change. I'm hopeful we can just get this done today, and then I can start on hyperparam stuff. Okay, PufferLib does not require 3 points, so I don't know what the hell's up with this. Oh, hold on. Yeah, okay, Python. Yeah, this is it. I don't know what the heck's wrong with pip. Also, let me go check for status update from NYU. No updates. I'm good with that. I got plenty of work to do as is. Really just huge amounts of work to do. Oops. What's up here? Oh, it's still going, okay. So we're gonna implement this exploration bonus algorithm without the inverse dynamics model to start, and see if it, just see if it does anything. Okay, so this now works. Lovely. Let's hope that we haven't completely destroyed our CUDA drivers. I can run this on the remote box, but I'd rather not. Okay, there it goes. Okay, so here, do we have hidden size somewhere? Is there nothing in here? In size? So this has it. I didn't know the hidden size. I guess you just make sure that it actually has it. If this works. Cool, that works. Batch size. Cool. Experience. Okay, so this is the E3B map. And then we do this. Now we have storage. And do we need to do anything with this map? I actually don't think we need to give a damn about any of the other stuff. It's not used in the loss function. It's only used in the reward. Yeah, so I think we can just... I don't even think we need the .numpy version. I think literally we just need E3B mat here. Okay? And yes. And this just gets returned basically as an extra state variable. So like action log prob E3B mat intrinsic. I think this is what it is. And then what you have to do is where's this? B mat. And then you do E3B mat. This. Okay. And then same thing here. This. And then all you have to do is you have to add the intrinsic reward to the rewards. So let me think how to do this. Device. Env ID. Right, because you could be getting different env IDs. But the rewards we just add to, I think. I think we just add to the reward. So we do reward plus equal intrinsic reward, like this. And then you have to pass E3. You have to get this here, like so. And actually, this has to be done regardless of if you have an LSTM or not. So this goes up here. Okay, and then this goes E3B, E3B. Cool. And now this has to get propagated into the policy. Yeah, this has to go into the policy. Let's just make this explicit. Just so we make sure there's no surprises here. I really wish my stream overlays actually worked. Welcome, YouTube folks. Okay, so what we have to do here is PufferLib. We have to add E3B to here. This is going to be state, action, and we'll just add E3B here. Okay. And this is E3B is none. X state E3B. And this should be good. And now this also returns intrinsic reward. Action value state. Now this has to return us new E3B, new intrinsic reward. Oops. See, yeah, new E3B, new intrinsic reward. So this is now going to return state E3 this. This is E3B and intrinsic reward. Now this is fine. This is now correct. And this is self.policy, so then we'll have to adjust that there. Let's do the same thing over here. We add E3B. We add E3B. There's no state for this one. It's E3B. And now this is going to return an additional E3B, an intrinsic reward. It supports E3B. Okay, so now this is everything for the clean RL binding. Now we have to modify our models. And I think that by default, all we really need to do is modify our recurrent wrapper, and our default would be a good starting point. So LSTM wrapper of policy. This needs to take E3B. Okay, and this is going to be encode observations. It's going to be in decode actions that we use E3B. Amusingly, this is a nice time to get rid of this lookup. I think I'll leave it though. So the thing with the lookup param is I think you actually need it for entity-based models, Captain. I think you actually need it for entity-based models. Maybe it should just be quarks or so, like quarks or something. I don't know. This is just on a separate branch, anyways. This makes such a mess of all the policy code that this is only going to end up getting merged to the main if it's really good. Isn't used. Yeah, that's fair. We're going to end up adding it back if we ever want to do entity anything, though. I used it in the old neural MMO policies. Basically, without it, you don't get to use the encode decode API. Like the encode decode API doesn't work if you don't have that for entity-based models. I mean, I'm going to redo a bunch of this policy stuff anyways at some point. It's on the queue of stuff to do, right? It's always a million things to do. Okay, so this should be enough for the LSTM wrapper. Now I just want to add this to the default policy. And this should be enough for us to run experiments once I debug everything. Oh, actually, hold on. This needs to go forward. Yeah, okay, so this goes into decode, and that's fine. All I have to do is I add it here. We just do E3B, like this. And then here, we're going to return actions value, E3B, and intrinsic reward. Now, we have to actually compute this. So what we're going to do is add the formula. And this is the tricky part. Here's the formula. So we do phi equal hidden detach. And then we do intrinsic or equals phi t like this. And then we do how do we do exponential decay? Oh, I think it's just going to be, yeah, it's literally just E3B next equals then it has to get initialized to something, doesn't it? One over lambda I. So it's lambda I to start with. What's lambda I? They give you lambda? They said it was pretty robust to lambda. Final value 0.1. 1 is what they use. So we'll just add 3B and this. Well, I think we'll hard code it for now because it's a pain in the ass. So it's going to be 1 times torque dot I hidden size mute. There we go. That's pretty clean. And now for this, I get their formula. Okay, right here, E3B next is going to be 0.9 times 3B, each step T, 5. So it's 0.95 times E3B plus outer 5 plus 1 . How do you like make a torch constant that gets moved to device? Register buffer. There we go. That seems pretty good. That seems pretty good. Yeah. Actually, I just do E3B. Okay. What are the odds that this runs? Oops, not this one. Not this one. CUDA out of memory. Holy. Tried to allocate. Okay. Is this gigantic? It's probably kind of gigantic, right? Hmm. Not really, it's just the batch size that's gigantic. But wait, you don't need these in a batch, do you? You don't need these in a batch. You need these in... You need number of environments of these. Okay, so I have the storage wrong. Luckily. Really? I guess this is just too big. I don't know. Um, Here, we'll do this. Still out of memory? I don't understand how this is possibly out of memory. E3B. Dot shape. This is like not that much data at all. Something screwy. Oh, that's why. It's just this. There you go. Default, no E3B. Expected. Okay, so we just have to fix some math here. So this is this hurts my head a little bit. So this is 128 by 128. So if you were to get rid of these, it would be it's phi unsqueeze. So it's phi dot unsqueeze 1 and times phi. Is that it? This is GPT. Screw this. It's been too long since I've done this. I have batch times side. C do. Isn't Einsam slow? What the hell's solve? Oh, interesting. Hey, Joseph, love your work. Wondering if you have any suggestions for more accessible projects for someone newish to RL looking to do some original research. For new RL people, I always recommend that you implement a simple, high performance environment yourself end to end and get something training on it. This is what I've had like all the new Puffer contributors do. You can pick something that will have like interesting science on it for sure, but that's what I would suggest. Give you an idea of all these environments. I implemented Neural MMO3, MOBA, and Snake. Obviously, I've code reviewed and edited all the rest of them, but like the rest of these are all by contributors that are mostly new to RL, and like implemented these as a way to get involved in it. So anything as simple as as simple as Pong, all the way up to like this is a more complex environment to implement. So is Go. Right? Any of these. This would be my suggestion. We have lots of examples, like all the code for those is open source and it's fairly simple. I mean, it's in C, but it's very, very simple C. Is this correct here? What are your thoughts on Lex Friedman? I have no thoughts on Lex Friedman. I haven't seen any of his podcasts. What are you trying to do currently? I am implementing E3B, or most of it, which is a RL exploration algorithm. And there's some funky math that I'm looking at. Wait, this is stupid, right? Okay, so this thing is better. Interesting. Okay, so let's just implement it this way then. So you're storing the inverse mat, I guess. Can you give me a learning path who wants to learn? Yeah, I have a guide on this on my X. It's also on the Puffer blog. Here. RL Quick Start Guide, right here. I have a very simple approach to most things that I think you'll find pretty accessible. The stuff I do involves, very little math, very little like complex stuff to think about. It's mostly just getting the basics down and doing them very, very well. The best stuff in my toolkit is honestly being able to write simple, high performance code. That ends up being more useful than most other things. For new people, I suggest like building an environment end to end from scratch and contributing it to PufferLib. Just go through that process of building an M for PufferLib and also training RL on it. Because you get the process of like what goes into making a brand new problem work with reinforcement learning. This is the best thing you can do. And it can be done in simple environment, can be done in a few days. Even if you're brand new, if you just have decent software engineering. Are you a PhD student? No, I'm graduated. I'm a MIT PhD. I finished up last spring. Now I work full time on Puffer. Okay, so I definitely want to implement this way. E3B. Call this inverse. 1 over lambda. This is 10, which is kind of sketchy. But I guess that's what it is. Is Puffer something like Gymnasium? No, because Gymnasium is just an API for RL environments. Puffer is a lot more than that. So Puffer has way higher performance distributed simulation compared to Gymnasium. We don't have as much API overhead. We have our own environments that we have made that are like 1,000 times faster than basically anything in Gymnasium. We have high performance training code. Gymnasium doesn't do training. We have ultra high performance training code. We have really nice logging. We have automated hyperparameter sweeps. Puffer is the project that I am building to make RL simple, fast, and easy. It's everything. You can see our demos on puffer.ai. They'll run live in your browser. So this thing here, E3B, okay, so I think this is good for intrinsic reward. And then we have to do this update to E3B, which is going to be E3B minus holy hell. What's the most efficient way to implement this thing? This is UUT 1 plus. Obviously this. So yeah, you compute this. I think this is a shit implementation that it just gave me. Am I frozen on stream? No, I'm not. Okay, good. Welcome, YouTube folks. What we are currently doing, we're implementing E3B, which is an exploration algorithm for RL. And there's a little bit of funky math here. Sherman Morrison, rank 1 update. And I'm just trying to make sure I do this correctly and I do this the most efficient way possible. I think that this is giving me garbage because so C inverse U, so this is fine, but then compute the scalar denominator outer product yeah, so this should be cached, right? Because this is UT and yeah, okay. So let's just make a little like German sun U. Let's do this. So return T cnv. What the heck is that? What VT T? So we do this, and then so that's now cached, and then we'll do this. I don't think this needs an unsqueeze. Cnv minus CMVT at divided by 1 plus. Should I focus to solve problem or anything else would be I'm not sure what you mean by that. Like learning algorithm. You're gonna get confused if you just start doing like learning algorithm ablations and stuff immediately. I generally think the best way to get into reinforcement learning is to go through the process of making a new environment and then going through the process of getting reinforcement learning to solve that new simple environment. Because that will teach you, that shows you how to structure observations, how to get data through the network. You're probably gonna have to do a little bit of hyperparameter tuning. You're gonna have to like understand the process by which environments compute observations and rewards and similar and parse actions and all of that. So like that's kind of the whole end-to-end thing. There's very little on the algorithm side of RL that really matters. Like everyone loves to go straight into all the fancy math and algorithms. Like PPO kind of just solves everything if you do it right. And yeah, that's kind of limiting, and there are probably some things out there, but like 90% of the people in RL are just spinning their wheels on algorithms right now. I would way more recommend just like going through the process of making and fully solving a problem. Building an yeah, so you're going to build an environment and you're going to solve it with reinforcement learning. So I'd pick something that is like relatively simple. You know, people have done Pong, people have done Breakout, right? People have done simple grid type environments. So pick like some simple little game that you're going to have fun building. Something that's going to only be a few hundred lines of code that you can do in like a couple of days. And then look at all our Puffer examples, look at how we've built them, and match that, and then go through the process, for your environment of extracting and computing observations, computing rewards, getting data, from many parallel copies together into the storage tensors, running training, doing hyperparam optimization, all of that. That's what I suggest. It's a very good way to get involved. We've had people do this that are brand new to reinforcement learning. You have Discord? Yeah, discord.gg/puffer. There are like 900 people in there. Lots of helpful folks. I mean, this is all on our website, right? Puffer.ai. We got GitHub, Discord, and X. All of these things. you can see all of our all of our environments here as well. If you just go to Ocean, like you can literally play all of these in your browser and watch agents play them. So like here, this is an agent playing Pong, RL agent playing Pong in your browser, and if I hold Shift, Shift, then I take over, and now I'm playing the game for the agent. Right, I'm taking over for the agent, and now I take my hand off the keyboard and it plays again. And this works with all of our environments. You can play around with them. They're all open source. They're all on the GitHub. Pretty much, they're all like one file each. Very nice and self-contained. They're very, very, very fast. We make it very easy for people to get onboarded. Okay, so here is Sherman Morrison. Let's see if I've done this correctly. Intrinsic reward. That's correct, isn't it? Okay, that's pretty good. Are you using multi-agent for Pong? No, Pong is single agent. It's like the original Atari game. The opponent is a scripted bot. We do have multi-agent environments though. We've got lots of them. Like here, we use Snake as multi-agent. Each of these is an independently controlled. This will train in like 2 minutes on one GPU. We've got Neural MMO. This is massively multi-agent. Tons of different things. These scripted bots are, these are scripted, but there are like 100 some odd trained agents per environment. MOBA is multi-agent. Each of these is a different agent. And I think there are a couple others, like Rware and Traffic are both multi-agent. So yeah, we got lots of multi-agent. It's the exact same thing as single agent, except when you have like highly competitive environments. It's not any harder, with Puffer at least. I mean, my PhD is in multi-agent, like many agent learning, so. Really? Some elements oh yeah, hold on. There we go. Oh, hold on. Am I screwed here? No, because you don't need this at train time. It's already computed the rewards. You don't need it at train time. So here we got entropy value, TM state. We don't give a shit about this, right? We do not care. And this should be it's just a reward addition. Okay. Device side probability tensor contains. Okay, so let's back up. Ooh, nans. Well, that's funky. Let's see, why is this not stable? One over lambda inverse, right? But they say that their lambda is, they got like a lambda of 10. I don't see how that's possible. But that's what they say. Ridge regularizer. Is this a different lambda? It's hyperparameters for E3B. And they do 0.1. So I don't know how that's possible. Yeah, they got 0.1 everywhere. Do they clip or something? I don't understand how this thing works. Because they're clearly, I mean, they're adding a giant matrix. So how does the thing work? Is my Sherman whatever formula wrong? No. Minus this thing. Wait, 1 over... Oh, this is clever. Hold on. They have a different formulation of it here. So we do B E3B B minus this is message. I'm a third year, hold on. I'm a third year college student. I'll be getting into a 7-month long internship soon. We'll have less workload. I've been thinking of learning NeoVim. I still use my mouse a lot right now. It takes all of 10 minutes. It really takes all of 10 minutes. Here. This is my whole config here, okay? I got Super Maven. I got Semshi. That's it. I got 2 plugins. The rest of this stuff is just color theme. This is just custom color theme. I got like a couple little options set and that's it. That's literally it. I don't do anything fancy. I just stick this into my base Docker container, and then I have my whole work setup in a container wherever I go. It's great. So this is a clever little trick that they have. Um, I think I can do outer b, and then I can do divide by 1 plus b. Getting used to it. I don't use that many. HJKL, move around. I use maybe like 10 shortcuts total. I really don't do. I mean, there are people that get way, way fancier than I do. I use very simple things. You'll be used to it within a couple of days. I used um I used just like Vim with no plugins for 6, 7, 8 years. I don't know. Okay, so let's see what's wrong with this thing. I mean, the question is if you want to get into RL, right? Like whatever editor is whatever editor. RL is fun. At least it's fun now. It used to not be too much fun. So it's got to be row, so unsqueeze. So unsqueeze 2, unsqueeze 1. Do you do freelance for work? Assuming this is not a passion project. Well, I guess it kind of is. Puffer is a company as well. We sell support contracts to companies that are doing RL and having a hard time of it. Technically, what I'm doing right now is part of one of those. So all our stuff is free. All of our stuff is free and open source. But we sell like support priority service stuff starting 10K a month for companies. I do it for free for academic labs. So I've got like 3 academic lab collaborations and some clients. We're definitely looking to expand Puffer over the next few months. I mean, I've been doing this since last spring. It's less than a year old. And progress has been really great. A lot of work. Definitely a lot of work. Pretty creative idea. Yeah, I mean, it's like this is not how I would monetize Puffer if that were the primary goal, but I think that this is a perfectly good way to revolutionize reinforcement learning, and I think it can be plenty profitable like this as well. The goal is really just to have like a small to mid-size industry lab that's just churning out awesome RL work constantly. We're well on our way. I mean, Puffer is probably the fastest growing RL project out there. You know, this is some good growth. This is when I went full time, right there. I don't know why I have these on still. I just left them on from my last meeting. Mm. Okay, outer product. This is unsqueeze 2, unsqueeze 1. Should be unsqueeze 2, unsqueeze 1. Okay. Now, really? Unsqueeze. Well, that's not good, right? Or is it? But maybe that is correct. Maybe that is correct. I'll just look and see how to problem solve since it's the favorite thing. Good luck on your stream. Sure thing. Thank you. I mean, stuff like this takes me forever because, like, I don't mess around. I used to be pretty darn quick at this stuff when I was doing a lot of architecture work, but now it takes a while. But then if you like it when I'm like going through code bases and fixing stuff, it's like super super fast. Some stuff's slow, some stuff's fast. I still get everything done. And then what is this? Maybe this is dot squeeze. Maybe we get rid of this dot squeeze. B dot squeeze. Maybe this. I don't like calling this B. There we go. Try this. The heck? Broke my terminal. Broke my terminal. There, try this. Hey, there it goes. Value lost. Yeah, okay. So this now runs, massively slows down the forward pass because they're inverting a bloody matrix. Let me think here. I mean, this makes sense that this is massive to me. I don't know how it's possible that they have lambdas what they say it is. Let me see, unless I have it implemented. Because they say lambda's 0.01, I mean, they say lambda's 0.1. So then lambda inverse is going to be is 10 times the identity matrix. And then they add 10 times the frickin' identity matrix every single iteration. So I don't see how that's possible. Oh wait, see, yeah, no, they add 10 times the... Just popping in to say, really enjoy your work, been following for a few years. Thank you. We're currently implementing E3B into PufferLib, seeing if this exploration algorithm does anything. My prediction is it's just going to be too slow. But there's some weird things with it. This is for our client. The thing I really want to do, which I'm going to probably do, if I finish this soon, I'll just start on that. But the next thing I want to do is look at carbs and really fix that hyperparameter tuning algorithm. That's going to be huge for Puffer and for RL overall. Because I found some bugs with carbs, or some design issues rather with carbs earlier today. How is this possible? Like, I'm gonna just drop this PDF into Claude and see. Like, I don't expect anything out of it, but like, usually it's like a confirmation that yes, in fact, this paper, like, this is insane, and it doesn't make any sense. Yeah, so, this paper, here's set lambda 4.1. Then, add this matrix, convert, it's adding 10x identity matrix iter blow up the inverse. There's no is added once, not accumulated. Oh. Okay, so yay, Claude for once is actually helpful. I got it. Did I get it wrong? Huh, yeah, I did get it wrong. Okay. Me stupid. Me very stupid. Hey, Captain, finished some env optimization now, 170K, training versus 130. Very well done. Very good. M speed's everything. M speed is everything. I'm interested to take a look at the, the way that Box 2D handles, because apparently there is a tree, you said, for collisions. Yeah, the rest is mainly Box 2D. So the question's basically going to be, when we strip down Box 2D, is there anything we can find that's slow there? Okay, I actually don't know what the hell an AABB tree is. I don't know, is that... I would think you would just want like a quad tree or something, or even just like a fixed grid, but I don't know. Oh wait, I didn't even add this, did I? I didn't even add this eye and it's still blowing up. It's fairly well optimized as is. Don't know how much we'll be able to speed it up. Interesting. I mean, the physics calcs in your environment, though, they don't seem like they would be capped to 100. Like, they don't seem that they would be capped that slow. You're handling, like, on average, a single-digit number of moving things, right? Yeah, mental math doesn't check out, Captain. There's got to be redundancy. If you have, like, thousands of entities, then sure, but you don't. Yeah, and all we care about is the average because you have enough parallel m's that it's going to smooth. What if I do this? Exploding value loss. Completely insane. I don't know why. How's that happen? How's the value loss that bad? I don't understand. Why is the value loss immediately garbage? If I just do this, okay, the value loss is definitely being screwed up by this calc. Okay, so this is training a little bit without the bonus. Just adding in the intrinsic reward. Okay, so this learns something, but it's very slow, right? But the value loss is stable. Value loss is stable, so then what happens is you add this thing on. What if I do 0.01? Maybe it's scaled. No, the value loss immediately freaking explodes. Still? Not as badly, but still, it's crazy. 0.001, yeah, no, it's still gonna explode. Is it like on the graph or something weird? No, it still explodes. How is that still exploding? Do they have a coefficient on this thing or something? B. Okay, they do have this beta. So let's see what they set beta to. One. They set it to 1. Jeez. They set this to 01 and this to 1. I don't know how this even works. Now look at the value. It's just exploded. I mean, I imagine that this decay is not the problem, right? Yeah, that's way worse immediately. Right. I'm pretty sure this is implemented correctly. I'm pretty sure. So and what do they do here? They do this B term. One over 1 plus this. 1 over 1 plus intrinsic. And they do this outer product minus that, which is fine. And how can the value loss possibly be that big when the intrinsic reward should be clipped? Let's go look at that. It could just be hypers, to be fair. Could just be hypers. So I don't really like the fact that I have to clip here. I'd rather clip the IC8M rewards, right? Okay, so let's try this next. Let's try this next. Okay, so the value loss is still crazy, but less crazy. Yeah, way less crazy. Now, is this summed or something? Like, why is the value function like that insane? It shouldn't be. Okay, so breakpoint here. Can you move the puffer? It's blocking the losses. Oh, this guy? Yeah, he likes to block losses. He likes to block losses. We'll find a nice stream overlay thing soon. I'm going to be streaming way more. Ooh, let's see, train. Where's value loss get computed? Okay, unclipped. What the heck? Well, that'll do it. Oh, because it's discounted returns is why. Okay. So yeah, if you have one reward per step, value is gonna explode. I don't understand how this thing of theirs works. Like, unless this improves. Why is the SPS so low? This stupid thing. Let me think if it makes sense that it's this low. Yeah, a mil. Should be about a mil. I mean, I can test real quick. Maybe this is not an optimal config, right? We can do. Where's the damn thing? Oh, interesting. So how is that not what's making it slow? That doesn't make sense to me. Try this. Okay, there you go. There's 600K. And okay, still 600K. And now with this, oh, that's funny. I guess it was the NumPy is NAND that bug check. Okay, so it does take a perf hit, a pretty big perf hit. Um, let's see. Its value loss is just way too high. Look at this. I guess it's the really big values that are the problem. Clamp and then scale. Oops. There we go. Doesn't train at all. Can run a full sweep, I guess. Okay, we will probably do that. Let me commit this for now. We need like a nice exploration environment. I'd like to have like a maze or something for this. You just send this over on Discord. Okay. Let me see. Let me just send this over, and then we'll see what we do from here. It's only 5. Okay, so that's that. Let me see here. Next thing. Next thing. Whew. I'd like to go get myself some tea or something, but it's a little late. I think we're gonna do hyperpram stuff next. I need to get myself woken up a little bit, and yeah. So, I know roughly what I want to do. So let me give you the outline real quick, and then I will come back in a few minutes and start working on it. So there's this algorithm called Carbs from MBUAI. It's a really good hyperparameter tuning algorithm. It's cost aware. The goal is it launches a bunch of fast experiments in order to build up a good predictive model of what hyperparameters are going to give you what performance. And then it launches slower experiments over time that give you higher perf. But I found some issues with the way that it samples parameters specifically that prevent it from essentially prevent it from exploring outside the initial space of hyperparameters that you give it very effectively. So the code base is very complex, very overly complex, I'd say, for what the algorithm is. And I'm probably going to go through and try to simplify it and see if I can get perf before and perf after to be, substantially better. I have a synthetic benchmark that's really quick to run, and I'm probably going to play around with that a little bit. That's going to be the goal. I'm going to have about an hour or so to do this. Yeah, I'm going to have about an hour to do this before dinner, and then I'll probably be back after as well. I'm going to go grab myself a drink real quick, take a couple minutes, and then we will get implementing that. And this should be pretty good because this will be a major thing for RL. Yeah. I'll be right back. Don't let me forget to unmute my mic. Okay. Okay. Here's what we're doing next. Well, first of all, I gotta check to make sure I don't have anything missing, because I was expecting an update from NYU on their stuff. But if they don't have it now, let's see. Let me just check this on the side real quick. Might have to do GPU drive stuff depending. Okay, didn't get to it. Cool. We get to do cool stuff. I have finished the log of work for today, so we get to do cool stuff for a little bit. Here's the deal. Here is the deal. This is a synthetic test. The max score is like 250. Carbs does not get there. Some parameters it fits nicely, some parameters it completely fails. We're going to now look at carbs and look at some of the stuff that I found earlier and see if we can fix some things. So, carbs. This is the generate candidate function. Sample around origins in basic. We get all Pareto obs. Pareto groups. Origins in basic. Pareto groups. So this samples around your Pareto group. Okay, and then right here, search distribution in basic. You have right here. So there are two issues with this. There are really a few issues with this. Quite a few, to be fair. Issue number one is the way that it is converting hyperparameters into a normalized space. That is not correct, the way it is doing that. Issue number two is the way it is sampling around the hyperparameters in that normalized space. Let me think about how I want to do this. It's very important that I get this right. Also wrong branch. So we got right here. Some of these are easier than others. Let's think about parameters in log space first. This is what that parameter looks like transformed into log space. Interesting. So you would actually like to transform your space Okay, so I see why I'm not getting this. Right now, I have a transformation into a good space for sampling. So what I do is I take log of this, right? And then I do +1, for instance. And then you do 10 to this. And lo and behold, you get 0.05. So if you take the log, and then let's say you grab some standard noise, right? You can see that this gives you some good samples, right? Because the standard deviation of 1 in log space is 1 order of magnitude. And then there's a clip factor so you can prevent it from sampling crazy things. So it's going to go up to 2 orders of magnitude in either direction. This is a very, very good thing for sampling. However, this is not perfect yet for fitting parameters. For fitting parameters, you would like the entire thing to be in the range of, let's say, -1 to 1 or 0 to 1, either way. So what does that transformation look like? Well, I think it's just like you subtract the midpoint, which is the -2.3, and then you probably just divide by 2 whatever sample you get, and you clip. It's a little bit sophisticated. So, do I make my own version of this? Do I modify the carbs version of this? I'd like to have my own. If I have my own version of this, I can make my own algorithms. To be fair, carbs will probably win. I'm trying to think though. So pretty much I think carbs actually has the right, they have the right API for this. Their function names kind of suck. But they're not that far off. So like if we look at their spaces, it's utils. Let's look at like log space or linear space. So they've got param from basic, which is if you give it a value, like a value of the hyperparam, it transforms it into a nicely normed space. Now their transformations aren't correct, but that's the idea. And then if you get a sample from that space, they send it back to you. And then when they do .observe, let me see. Add observation. See, they convert it to basic space again. How much code is in this repo? Like, we don't really care about this serialization stuff, right? There's this model. It's a giant-ass utils. Maybe 2,000 lines total in this repo. I think we could get it to 1,000. The first thing I want to do is figure out how to fix it, though. So maybe what I'll do is I'll leave everything alone, but I'll fix their transformations to start. I'll fix their transformations, and I'll fix the way that they're sampling around their transform data. This should have a sample on it. Oh, you know what? I kind of see what they're trying to do with this scale. I actually kind of see it. This makes sense actually to me. Yeah, no, they're correct. So the idea is that all the samples are normal. Um, See, for a uniform space, does this make sense? It still kind of does make sense, right? If you have some prior on like what the mean should be. But their values are not correct. Okay, so basic from param. This should be like return value minus that's 0 to 1. Okay, so this should be that. So that gets you to this. And then param from basic value is going to be equal to what the heck? Plus 1 over 2. So this is going to undo it. If is integer and is rounded. Okay. This rounds. And then they need a round operation in basic, which is kind of weird. Do they use this round tensor basic? Kind of weird that they do that. I guess it's they want the rounded whatever. Why don't we just do equals param self dot param from basic value, and then this rounds, right? Yes, true. And then we do value equals self.basic from param. Isn't this just work? Yeah, that should just work. Much easier. And then we can do the same exact thing here, right? Okay. Basic from param. Basic from param. A little trickier. So we're going to log the value. We do mean equals Is there no mean on this? Search center. Why don't we do search center, right? Self search center. And then we do self dot. And this is clip, not scale. And you should never be able to sample 0. Okay, so param from basic. I think this works. And then if it's rounded, you round and you return. Not bad. Only really 2 more spaces here. And then we'll be able to test this. You know, even with their search term, this actually should work. If I do it this way, it should work even with their search term. We're gonna have to clip as well, but basic from param. Let us think. Value equals 1 minus value. Map.log 1 minus value. Self.base. Base is 10. We shall see about this. That's 0 to 1 scale still, so I'll have to fix that. And then there's never any rounding here. So you just return the value. Then param from basic. You see? So multiply by clip. Then you add search center. You take I'm getting really tired. This is stupid, but I'm gonna do this. And then I hope I don't get bitten by GPT failing something that's simple. There we go. The 1 minus goes to the start, obviously. I'm just tired. There you go. Return. Cool. So this is good. Where's our POW 2? POW 2? I thought I had a POW. Isn't there a POW 2 space or whatever? Did I put this to a new branch? Is this a new container? Ah. Like this. So basic from param. So we do scale, min, max. That's not quite right. I think it's actually very similar to the log space and its scaling. Isn't it just this? Wait. I think it's just this. Search center. Thing of the search center. Yeah, but the search center is off. But it'll be fine. I do Right. Okay. Oh, yeah, I see. It's gonna get rounded though. So I see. So you do value, mean is gonna be 2 to the log max. Okay, so we do value equal value. We got log 2 value minus mean and then what? Something like this. Integer surrounded. Well, this is supposed to be basic from param, first of all. And then param from basic. Get your value. Value times mean. We're gonna fix all this stuff up later tonight. Just a prototype. And then now you round it. And then you return 2 times value. And round tensor in basic is just gonna be, we get to eliminate all these obnoxious functions. Okay, so that's all of them. And all I have to do is clean these up a bit. I actually don't like the way that I've specified parameters. I think I don't like the way that I've specified clip. I think mean, scale, min, and max are going to be the parameters. Yeah. It's going to be a little bit of work. The way they use scale is currently confusing. Yes, it very much is. The thing is, their stuff is wrong, Captain. It's confusing because it's wrong. Shoot. Also, you can't do... The mean doesn't have to be 0. Actually, the mean can't be 0, the way I'm thinking about it. So confusing. It's kind of difficult to explain the stuff I'm thinking about at the moment. But basically, I'm trying to figure out a good space to transform. I'm basically trying to figure out how I want to parameterize each hyperparameter, and then what latent space I want to transform them into that's going to be good for learning a predictive model, as well as for sampling. Let's say that we have a log parameter. Actually, let's go even simpler. Let's say that we have a uniform parameter. There's a min, a max, and a mean. The mean is not exactly between the min and the max. So that means we want to sample around the mean, and we want to get values from the min to the max. How do you transform that parameter? Easiest would just be to rescale it between -1 and 1. Then what you would do is you'd search, you would sample from the search center. Doesn't have to be 0, that's fine. You'd have a scale parameter. And we'll think about how the scale param works, but you can have a scale param. So you sample normal distribution around that. You clip to min and max. And you transform back. I think I know how to do that. So mean, min, and max are obvious. What about scale? Scale is going to be kind of confusing. So for symmetric distribution, three. This scale's pretty good. Is their default actually good? I think their default might actually be good. I mean, it kind of depends on the parameter. 0.3. It's kind of good. Might not even need a scale parameter with this. I guess, hold on. Do you need... You might need it for something like total time steps. I'm gonna have to think about that. I think, well, let me check. I think I might be getting called here. Okay, I gotta go. I'll be back in like an hour.